So looking at this question here then, I'm just going to share my screen as well, actually, that bit. So we've got three types of radiation, and the Geiger model tube is detecting it, and using like counts per minute is going to how many counts per every minute. So let's have a look at a Geiger model tube. Okay, so this is a picture of a Geiger model tube. That's the actual tube, and then it connects to just this receiver here, which is basically just giving us the reading. If we look inside it in this diagram, we have a wire. We don't need to know much about this at GCSE, but you need to be generally aware of how these things work. So if you want, you need to be able to just follow an explanation like this, but you won't need to. They won't ask you a question, how does a Geiger model tube? And they won't need this much of an in-depth answer. But in any case, yeah, so you've got this metal tube, which we call the cathode, and that would be receiving electrons or negative, not receiving electrons, it would be receiving positive ions, because it means it's a negatively charged electrode. So the outside is negatively charged, and the inside wire is positively charged. You then got so you've got a low pressure gas, usually argon, in the middle, flowing all around. And then if you got something like perhaps gamma radiation going through there, it would go through this thin mica window. So it would manage to go through that. And what would happen is they might cause some of the particles to ionize. And that means that an electron would be removed from one of these argon atoms and would go towards the anode. Because of that, we have basically an ammeter or a voltmeter or something like that connected, and that would measure a current flowing. The current would only flow if one of these electrons leave the argon particle and join this anode here, and that would complete the circuit and produce a little count. So that's basically what happens. If there's radiation, the count meter measures a count. And what we're saying in this question is the background radiation, in other words, we're always going to get a certain amount of radiation because things in general are, there's radiation everywhere, whether we're near anything specifically radioactive or not. Then the normal one is 0.3 counts per second, and the count reader measures 819 in 60 seconds. What is the count rate for this particular rock? Okay, that's then. So we've got 819 per 60 seconds. So if you divide that by 60, that gives the amount per second. But this is including the background radiation. So you then would subtract that by the you would subtract 0.3 from that, giving you 13.35 counts per second.